Impossible to miss nowadays are recommendation algorithms. They're omnipresent and unavoidable at this point. Whether you're shopping for clothes or utilities from your bedside, checking Twitter to see who got cancelled today, or opening TikTok for the 17th time while lost in an improv lecture. But what are they actually? And how do they work? The system behind the recommendations we see every day uses deep learning neural networks. So, basically, to make a recommendation, you need an input and a series of layers to create an output. And, of course, artificial intelligence. These algorithms use a combination of data and machine learning and operate in a four-step process. The first step is collecting data from the user. This can be explicit data such as likes or reviews, or implicit data like search history and click through rates. Then, this data has to be stored into a database where it will be processed and categorized. The final step is to filter the collected information, selecting the most relevant data required to give recommendations to the user. Typically, one of three different algorithms is used for this process, depending on the context of application. Collaborative filtering compares a user's behavior to that of others and recommends items that are popular with users of similar interests. Amazon is an app that uses collaborative filtering. The AI analyzes what similar users buy or look at, then each item is added to a neighborhood of other related items, and finally, it makes recommendations using items from the same neighborhood. Content-based filtering only considers the data profile from one customer and suggests items that are similar to what this user has consumed before. An example of content-based filtering is Spotify. The feature is called Enhances, and the AI behind Spotify Enhances analyzes different characteristics of your listening history and gives you song recommendations that you might enjoy based off those characteristics. These two algorithms can be combined into a single filtering system that considers both similarity in user behavior and the properties of items. Netflix is the best example for hybrid filtering. The AI of this app uses your and similar users' watching history, and for every show or movie, it will calculate a score. The higher the score is, the higher the chances are that you will enjoy it. Now, of course, there are two sides to this coin. Companies love using algorithms like such because it boosts factors like overall customer engagement and satisfaction, consistency of recommendation, and especially amount of sales. Other positives include higher discovery of similar or relevant items or content, which leads to a more personalized experience, along with valuable data sets for the company to work with. On the other hand, these algorithms can lead to questionable privacy policies due to the amount of user data needed for a well-oiled algorithm. When this data is missing, it will also be difficult to discern user interests, making so-called cold starts difficult. Another problem, which for example Amazon faces, is the addition of new or similar items to the product list, as the algorithm will have trouble sorting these into the right slots for proper recommendation. While some may be hesitant to trust these processes, and for good reason, it is undeniable that they not only work, but work really well. Overall, these algorithms provide a very comfortable user experience, while also being an effective method of maximization